When I first started this section, I wasn't even sure it was worth making a video about the steering box rebuild. I thought it'd be a simple disassemble, grease, and a paint job. I was wrong. What I thought would be an easy task turned into a whole journey full of unexpected challenges, like more side quests than the video game I'm playing now. I did expect challenges, so it's all part of the process, and in the end, all these hurdles led me to the EPAS conversion. EPAS, Electronic Power Assisted Steering, wasn't originally on the menu, but here we are. Challenge 1, the Spiromatic. So the first issue I ran into with the steering box, specifically the steering rod, it's got a solid steering shaft, affectionately known as the Spiromatic. Instead of a typical breakaway or rag joint, this setup has a 4-foot-long steel javelin pointed directly at the driver's chest. But in reality, an accident of that magnitude, you're likely not walking away from anyway. I was okay with this setup at first, but upon inspection, I noticed some issues. The cone where the steering wheel attaches was pretty worn out, and the area on the shaft where the compression fitting is was pretty worn as well. The compression fitting keeps everything centered. I tried welding up the cone and the bearing surface and turning it down on the lathe, but that was a disaster. So the next step was to find a replacement steering box. I went to the local junkyard but had no luck. The few boxes with the Spiromatic style steering I found were way too rusted to salvage. Eventually Ford went away from this and went to rag joints, so the Spiromatic styles were phased out in the late 60s. I even thought about converting it to a rag joint system and grabbed a candidate from an early 70s Maverick GT, but as soon as I tore it down, I realized it was in terrible shape, probably damaged by decades of water setting inside it. Another snag was finding a rebuild kit for the original Fairlane box. I ordered one. It was completely wrong. Fortunately, the original bearings were in great shape, so I had that going for me. At this point, I had a rebuildable box with a damaged shaft and no decent replacements. After some internet forum digging, I found a potential solution: the Toyota Prius EPAS conversion. Challenge 2, the EPAS conversion. I had it on good authority that the 2007 to 2009 Toyota Prius had a self-contained EPAS module that could run on 12 volts standalone. No need for an OEM computer, it just goes into limp mode with about 40% assist. For the people who've done the conversion, they say that's plenty of power to replace the OEM Ram-style hydraulic power steering. There is also a module that you can buy that will give you speed-dependent power assist. In other words, the slower you are, the more assist you get, and then the faster you go, the less assist. I definitely see that in my future. After scavenging 3 junkyards and several weeks of searching, I finally tracked down all these parts. These units are hard to find since the conversion is pretty well known at this point. Now to the meat and potatoes of the retrofit. In theory, it's simple enough. The plan was to strip down the Prius unit, graft the classic Ford tube and shaft on the cabin side, and then connect it to the box. This way I could keep the OEM box in the lower shaft section for that stock look. Not that anyone would notice past the other non-stock parts in the engine bay. The tricky part was the steering wheel side. The measuring was difficult due to the geometry. I did a quick fit up with the stock parts to get everything within a few millimeters. I'm hoping I can reference all these parts to get my measurements. Another issue was the original tube was for an automatic and had a different style blinker housing, as well as other parts cut out for the column shift. So I started hunting down a column tube for a manual setup, and as you might have guessed, this was impossible to find. I did, however, find a floor-shifting steering column from an early 60s Ford F100. I pulled it out of the junkyard thinking I could use it. I was originally intending to use it for a rag joint conversion, but it had everything needed for this new approach. The only thing it didn't have was a provision for the hazard lights, but that's an easy fix. I plan on relocating the hazard switch to an underdash switch. I initially used the factory Fairlane steering wheel for the fitment, but I later found a GT-style wheel. Unsurprisingly, the flange distance was a bit different. The tube distance stayed the same, so I felt comfortable cutting the tube, but I did want a way to adjust the shaft length. I cut the Toyota spline shaft where the Toyota bearing was mounted. This is where I planned to graft the Ford shaft. A lot of mistakes were made on the lathe, which you probably will point out in the comments, but I learned a lot along the way. I wanted a machine fit that was loose enough for welding. This is where I ran into trouble when trying to repair the original shaft. I think I got the fit too tight and it warped when I started welding. It was a learning process, and while this was probably painful to watch, it was certainly educational. The idea for the flange distance adjustment is to use a set screw on the spline shaft. The Prius just used a friction clamp, so I'm confident the set screw will hold. If it fails, the only issue will be about a 15 mil pull of the steering wheel before the set screw runs into the shaft, which will be terrifying but non-threatening. The main mounting point for this whole setup is the pedal assembly. Initially, I made some major cuts to the box to clear the EPAS system, but ended up welding most of those back to the stock form. That mistake cost me a couple weeks. I also had clearance issues with the underdash hydraulic system, but adding a 1/2-inch spacer to the column solved that. After the adjustment, I was able to rotate the EPAS motor pretty much under the dash. The only visible sign this car has an EPAS system is a small 1/2-inch gap from the top side, which in my opinion is a reasonable compromise. The single strap style clamp holding everything in place was pretty solid, but I wanted to try to use a universal joint coupler before committing to a solid coupler, so I added a bracket to the mount of the back of the EPAS motor assembly. It worked great. Challenge 3, creating work for myself. I didn't 100% understand how the geometry of how the underdash clutch pedal worked, so I foolishly thought the bearing modification to the pedal assembly would have some merit. It did not. I replaced the pot metal bushings with these fancy roller bearings and cups, and it was 100% pointless. It cost me about $15, but the time spent was a total waste. The way the clutch pedal was set up made those bearings useless. C'est la vie. Still, I got some extra time on the lathe, so I guess that was a small win. Now I felt confident with my measurements. I finally started cutting into the hard-to-replace parts. I transferred my measurements to the shaft I trimmed and got it ready for the spline shaft union. I did discover that running the lathe in reverse helped the chips from hitting the camera, but that was likely unnecessary. I am a tad lens shy from the last time I damaged the lens from welding. I don't have the proper tooling to hold these parts, and my lathe wasn't big enough to handle something with a lot of weld-over material, so I decided to use the lathe as a welding workstation. No major issues. I did keep all the parts cool with air to prevent warping. I did a quick pass to clean up the welds. It wasn't necessary, but it was already chucked up. I was pleased with the union and no major runouts from the part. The factory setup had a thin metal plate that really only held the gasket, so I needed something sturdier for a mounting point. I'm a big fan of riv nuts, so in they went. I knew I'd have many fitment passes and didn't think the sheet metal screws were up to the task. Like before, I did all my tests with cardboard. It made it easy to get the dimensions from all these points and angles. Using this type of rotating bearing, the firewall plate will indeed act as another rigid point for assembly. I'm unsure on how the universal joint versus the solid coupler will interact with this, but we'll just have to find out. But I was surprised when the shaft was locked in, it was very compliant and seemed like a non-issue. Challenge 4, Side Quest. I could have knocked this plate out with an angle grinder, but instead I spent a few months building a better plasma CNC. I think it was totally worth it, and right after that, I built a powder coating oven as well. Honestly, I'm happy with how the parts turned out. Even though it took time, I think this investment will save me a ton later when it comes to making parts faster. It was also very cool to 3D print the riser block for fitment and then take the same CAD design, send it straight to the plasma CNC, and make a real part out of metal. It's now time to start locking in the measurements and making the final adjustments. I'll need to restore the GT wheel, but it's pretty solid overall. The horn section on this wheel is fantastic. The aftermarket wheels look good, but they all have the triple horn elements in as a cosmetic detail. They're not functional. This decision might come to bite me, but I'm going to stick with the OEM style GT wheel. The column unit mounts with 3 set screws around the base of the EPAS unit, which will let me fine-tune the rotation. The spline shaft also has independent adjustment for the flange distance. The last nerve-wracking part is to cut the Spiromatic shaft to length and create a D shaft to mate to the EPAS coupler. This mini desktop mill is a new toy that I've been really needing to learn and am honestly fumbling with. There's so much to learn with these tools. Another part that's painful to watch, but I was able to create a D profile and it fits perfectly. A reasonable person would have done this with an angle grinder in about an hour. The new gasket was super easy to make on the laser cutter. The assembly was simple after I understood how to load the bearings. I tried this about 5 times before I understood how they were to go in. For the keen-eyed, you might notice some extra bearings on the workbench. I did pull some from the other steering box I had abandoned, and I looked for the best combination of bearings. Some of the original bearings were pitted, so I figured I'd sort through them and grab the best ones. These were not forgotten, these were just extras. Same goes for the needle bearings. Since all the Ford truck guys get their redhead steering box, I decided to add a little touch of Ford blue to mine. It took a while to find the right NLGI number 1 grease for the box. This was likely unnecessary, but I'm sure the engineers had a reason for calling it out. It seems like most people use number 2 grease that's readily available in every auto parts store, but I wasn't in a rush, so I had the grease shipped. I did pre-pack the bearings before using the method outlined in the book by removing one of the screws and moving the steering from the right to the left. I figured a little attention to detail here wouldn't hurt. I set the adjustment to feel, but I'm pretty sure this will need tweaking once it's under load. Now it's time for the final fit up. Nothing special about the outside parts, they're pretty much stock. The roller parts look identical to the factory ones, so no one will ever know. The pedal assembly can be built outside and installed later. It is a super tight fit in there. I did have a hard time getting good footage of the install. It's very tight, and most of the shots were to my back. I did pull a GoPro out, but it was so hot in the garage, the GoPro started overheating. Clearly, the inside parts do need paint, along with the dash. But this phase of the project has taken way too long, and I decided this was a good stopping point. The physical build is done on the E-Pass. I am honestly relieved to have this part out of the way. What I thought would be a small detail ended up taking months and months. Now that this is off my plate, I'm looking forward to knocking out some of the simpler tasks to build up some momentum.